Hello friends, Jim here, Science Talk, and here's an interesting study that has just been published. The author is Jordan Wilkerson, who is a Harvard graduate student, who's the lead researcher, and the report has been published in the journal Atmospheric Chemistry and Physics. And what did he report on? Well, there's another hazard linked to the thawing permafrost, namely nitrous oxide, commonly called laughing gas. And this, however, is no laughing matter. In a series of flights flown over the north slope of Alaska, detected unexpected levels of emissions of nitrous oxide, which is a greenhouse gas. Where were they emitted from? The rapidly warming soils, the ground. Nitrous oxide is an estimated 300 times more potent as a climate warming agent than CO2. It was present in data recordings at levels at least 12 times higher than all previous estimates. It also lasts a long time in the atmosphere. You know, methane is about like 80 times more potent than roughly than CO2, but it tends to break down sooner than CO2, so it doesn't persist as long. But of course, if you keep leaking methane, you're going to replace whatever methane already there has been breaking down. So you're still going to have the effects of the methane. It's not like, phew, you released all the methane, now we just wait for it to all subside. No, the methane keeps being released, the CO2 keeps being released, and now we got nitrous oxide. And it's 300 times more potent than CO2, and it hangs around the atmosphere for about 120 years. Yee. And if it makes its way higher into the stratosphere, it can be converted by the action of oxygen and sunlight energy into another oxide of nitrogen, which will then break down the ozone layer. Right? You might recall there was some years ago about CFCs, chlorofluorocarbons, you know, from refrigerants and that kind of stuff. They were breaking down the ozone. Right? We saw the famous ozone hole over Antarctica, and they've been banned, and now the ozone layer has been recovering. Well, nitrous oxide, here we're thawing the ground out, we'll release the nitrous oxide, it won't warm things up more, so persist for 120 years, makes its way up into the stratosphere, will be converted into a chemical that will destroy the ozone, allowing more UV radiation to reach the surface. Talk about shooting yourself in both feet. Now, nitrogen is an inert gas. Makes about 79% of the atmosphere. Plants need it. You know, plants use it to build a tissue. Nitrogen is a component. In fact, we all need nitrogen. Nitrogen is a component of amino acids. Amino acids are built up to make proteins. Proteins are structural. Proteins are regulatory. You know, so we know that plants absorb the CO2 from the atmosphere, photosynthesis, whatever, but they need the nitrogen to help. Not all the CO2 goes into glucose or carbos. Right? Some of it goes into making amino acids, which make structural, so that, you know, you get your stem, your bark, your leaf, etc. However, they can't just open up the stomata and suck in the nitrogen from the air. Unfortunately, it doesn't work that way. They need the nitrogen to be in another form. Using nitrites or nitrates, they need to be in another form. And often associated with the roots of plants are what's called nitrogen fixers. Usually they're microbes. And these are bacteria or other kinds of fixators that are able to directly take the nitrogen from the atmosphere, and then they convert it into a compound that the plants can use. And there's a little symbiosis between the plants and these fixers, and then the plants get their needed nitrogen. And what the plants do is, in return, they send some glucose to the fixer's way, so they can have energy to metabolize. Well, this process is natural, but it's too slow to help grow the needed cereals, tubers, other plants that people need. For more than 100 years, nations have been making nitrogenous fertilizer in factories and applying it generously to soils to boost harvest yield. You go to your local, greenhouse supplier, you buy a bag of fertilizer. What do you see on the fertilizer? You see three numbers. And the three numbers are basically what's going to be nitrogen, potassium, and phosphorus. And different fertilizers have different levels of these numbers, of these elements there. And depending on what you need to do, you would get the appropriate one. But that's what you typically see in a bag of fertilizer. Nitrogen levels, potassium levels, phosphorus levels, and NKP. Well, so we're kind of part of the problem here, aren't we? So now nitrous oxide is the third most significant greenhouse gas. CO2, methane, the other two. And the news that is arising from the permafrost could be troubling? No, it is troubling. It's a kind of bit of an understatement. So as we know that, as there's stores of organic material frozen, locked away in the permafrost, as the permafrost begins to thaw and warm up, microbes start to act on that organic material, and because it tends to be in an anaerobic situation, methane is a product of what they release. Well, now add nitrous oxide to the mix as well. Now, of course, imagine now you add nitrous oxide, what we're going to do to the warming. Let's add to the positive feedback loop, shall we? So what does Jordan Wilkerson state? Much smaller increases in nitrous oxide would entail the same kind of climate change that a large plume of CO2 would cause. Let's pause and reflect on that for a moment. What he's basically saying is a small amount of nitrous oxide can do the same amount of damage, have the same effect as a large plume of CO2. That is indeed very troubling. He goes on to state, we don't know how much more it's going to increase, and we didn't know it was significant at all until we started doing this. So, again, they're flying over the North Slope of Alaska. And they said, why are they flying over the North Slope of Alaska? There's two words, Prudhoe Bay, which is a big oil industrial sprawl on the North Slope. That's what's going on up there. So, they were flying around up there, and they detected this. Now, why they were flying was to measure CO2, measuring methane, measuring water vapor. And they came across nitrous oxide. So there are your four major greenhouse gases, right? CO2, methane, nitrous oxide, water vapor. One-fourth of the northern hemisphere is home to permafrost, which equates to 23 million square kilometers. The flights covered only 310 square kilometers in total, and only in the month of August. So, what could be true for one part of the year may not apply to the rest of the year. That's a fair, valid point. Maybe it peaks, the levels, June, July, August is when it peaks, and then it falls off during November, December, January. That's likely. But the point is, this is now another parameter that needs to be considered. You've heard me state before that methane is what keeps climatologists up at night, because they don't know what the potential is locked away in the permafrost. Well, now if we got nitrous oxide, holy shit, we're screwed if this is also going to be released. It's 300 times more potent than CO2. It lasts 120 years. Methane is 80 times more potent than CO2. Doesn't last 120 years. So now you got nitrous oxide that's almost 4 times more potent than methane. Eesh. So this is troubling. Again, so like everything else, we've got to figure out how much total is there, what's the rate of release, when does it get released, is it steady or are there peaks? You would think that as the ground cooled off and froze up during the winter month, that this activity would also abate. That would be logical, but again, you need to actually verify that with measurements and testing, etc. But this is another parameter, another factor that had not even been considered. Now, there it is, it's got dumped in our laps. And now we have to start thinking about this. So, it gets more and more interesting, does it not? Thank you for your time. Hey folks, this is Jim here reminding you to please subscribe to my channel and please share my videos with others. Also remember to click the bell so that you know when I drop in a new video. I also ask that you please consider becoming a patron of my channel and support the work that I do by going to patreon.com/Science Talk with Jim Massa, each word separated by an underscore, and becoming a patron. It's asking for as little as $3 a month, cost of a cup of coffee, to support the work I do and keep my informative videos coming your way. Thank you for your support.